Hello and welcome to an SSI guided tutorial. Today's video will be a continuation on the virtual nLight pre-construction meeting. This video will cover the fundamentals of installing a networked nLight system. If you haven't checked out part 1 of this series, do so now, as we will be building upon topics discussed in the previous video. Also, be sure to check out the nLight Pocket Guide, linked in the description below. Let's dive in. A networked nLight system allows for time clock events, global actions and sweeps, and if purchased, BAS or BMS integration, in addition to a suite of reporting options for end users and facility managers. Again, this video will be focusing on the wiring, topology, and testing of a networked nLight system. A networked nLight installation is similar to a standalone nLight installation in that they both follow the same Cat5 daisy chain topology. What sets a networked installation apart from a standalone is the inclusion of the nLight Eclipse lighting controller, the brain, if you will, as well as the nBridge 8, which allows you to further expand the nLight network. Let's start by talking about the nLight bridge, the nBridge 8. As the name implies, it has 8 Cat5 ports on it, which allow you to expand your nLight network. One of these ports will be used to communicate back to the Eclipse controller, while all other remaining ports can be used to add devices onto the network. For example, if we had a standalone nLight installation, or room, and we were to run a Cat5 cable from the last device in that nLight loop to an available bridge port, we've now just made that room networked. nLight bridges have an LED indicator on each one of the RJ45 ports that will blink device status or error codes. Keep this in mind and refer to the nLight Pocket Guide on blink error codes for an nBridge 8 if troubleshooting is required. Also, avoid looping a room from one bridge port back to another available bridge port to avoid communication and device errors. Lastly, nLight bridges do require a 24-volt power supply, which comes with the unit. Keep this in mind when planning your material needs. Be sure to always follow the Acuity-provided line diagram. If a deviation was made, ensure to document which bridge and which bridge port is now controlling what room or segment. Now let's talk about the nLight Eclipse. It should contain the following items within its enclosure: Wi-Fi antenna, a GFX G2, and a PS150. The PS150 will power the GFX G2. The Wi-Fi antenna allows for wireless interfacing with the controller for programming purposes. Take care when installing the Wi-Fi antenna. It's fragile. Pull, do not twist. You can mount the Wi-Fi antenna right onto the enclosure through one of the knockouts. Let's take a closer look at the Eclipse. Its enclosure will have a transformer on the inside to convert 120 volts down to 24, which will power the unit. There is a knockout in the enclosure in which you can pipe in high voltage. Let's talk about the multitude of ports the Eclipse has, starting with the 2 nLight ports. These are the ports you would use to connect nLight bridges back to the Eclipse controller. In many cases, only one of these ports gets used. The Eclipse does have a 3rd nLight port. However, this port is dedicated for use with the GFX G2 unit. You cannot connect any other nLight devices or nLight bridges off of this port. The Eclipse also has network capability. It has 2 Ethernet ports for which you can add the controller onto a local area network. As we've discussed, nLight carries voltage on its Cat5 wire, so you do not want to plug an nLight Cat5 cable into either of these 2 Ethernet ports. Lastly, the nLight Eclipse has 2 USB ports on top of the unit. This is where you would plug in the Wi-Fi antenna or nLight air adapter. There's another lighting controller that Acuity Brands manufactures called the nGateway. We'll cover this device in more detail in another video, but the information discussed here regarding networked nLight installations can also be applied to the nGateway. Let's return now to the idea of out-of-the-box functionality. As we've discussed, an nLight zone consisting of 2 switches and 2 power packs would behave as follows. Switch A and switch B would both toggle power packs A and B until separated through programming. But now let's introduce an nLight bridge. Each port off of an nLight bridge behaves as its own separate nLight zone. So, if we had switch A and power pack A plugged into port 3 of an nLight bridge, and then switch B and power pack B plugged into port 4 of an nLight bridge, the A devices would not communicate with the B devices and vice versa. That option does, however, exist through programming and the use of global channels. When installing these devices, it's very important to grab one of the loose serial stickers off the device and place it on a reflected ceiling plan where the device is installed. This will be vital for your field service engineer to accurately and efficiently start up a site and troubleshoot more effectively if necessary. nLight-enabled fixtures will have the sticker directly on the fixture, and if the nLight-enabled fixture has an embedded sensor, there will be 2 stickers. Grab both. If you have properly terminated Cat5 cable and have followed the daisy chain topology, your nLight system should just work out of the box. Your field service engineer will be able to finesse the lighting controls operations through programming. If you have any hardware design-related questions, be sure to contact your lighting representative for any design clarifications. For any technical hardware questions or inquiries, please feel free to reach out to System Support and Integration. Visit our website, www.system.support. Additional resources are available in the video description below. Shoot us a like and subscribe as we keep providing more content on helping make controls easy. Thanks for watching.